Hey guys, we are going to be starting Unit 3 and beginning with imaginary and complex numbers. So to begin, in this first lesson, we're going to start talking about I, which is going to be a number that we begin to deal with quite a bit. And then we're going to be able to simplify expressions to a point where there are no negative numbers under a radical, and these two things are very directly related. So we're going to start off by simplifying an expression, or solving a quadratic rather, that is something we're very familiar with doing. We have to find the roots of this function here algebraically. So what I would do to try to find the fast way to do it, I would list all my factors of 5, and I would try to find factors of 5 that add up to positive 4. And it turns out there are none. So this is not going to work. So that means I'm going to have to use the quadratic formula, and I'll go ahead and do that here. Okay, so I've set up my quadratic formula, and it's going to be pretty quick to simplify, I think. We have the square root of 16 minus 20, all divided by 2, which is going to be the same as negative 4 plus or minus the square root of negative 4 over 2. And this is where we run into a situation, because the square root of negative 4 is not a perfect square, but 4 is. So I could rewrite the square root of negative 4 as the square root of 4 times the square root of negative 1, right? These are the same thing. And then if I simplify this, I could take the square root of 4. The square root of 4 is 2. Still don't know how to deal with this radical negative 1. But I do know that at this point, I can rewrite my roots as negative 4 plus or minus 2 square root of negative 1 over 2. And even further, I could then divide by 2. So here we are. We're at a situation where I don't know how to deal with this negative under a radical, and I'm able to simplify it to this point, but this is really all that I can do. Well, let's just quickly investigate this square root of negative 1 just a bit. 1 times 1 is 1. Therefore, the square root of 1 is 1, right? Makes sense? Okay, now if I try to say that the square root of negative 1 is anything, let's say it's 1. Obviously, that's not true, right? Because 1 times 1 is negative 1. If I try to say that the square root of negative 1 is negative 1, well, I can try that. Negative 1 times negative 1 is, nope, it's 1 again. That just goes back to here. Which reminds me that when I do take the square root of 1, like I did here, I could be talking about 1. I also could be talking about negative 1, right? But the other thing that I've learned here is that I cannot take the square root of a negative number, because it's not possible for you to take a number, multiply it by itself, and ever get a negative. So what we have to do is we have to define this case as non-real. This cannot have a real solution. So what we do is we say that we're going to use this term I, this number I, to represent any square root of negative 1, which is the simplest case of a negative under a radical. So if I have a negative under a radical, I have I. So the last thing I'm going to do here is I'm just going to replace that with an I. And now we all know that when I put that I there, I'm talking about an imaginary or a non-real solution, because I can't take the square root of a negative 1. So my two roots would be negative 2 minus I and negative 2 plus I. So what I'd like to do now is just investigate I a little bit further, because I has some interesting properties. We'll begin with the fact that I is the square root of negative 1, which we all just learned, and that's true. But what happens if I square it? Well, if I square I, that's actually the same as squaring the square root of negative 1, right? And we know that from squaring things in the past, for example, if I have the square root of 4 and I square it, that equals 4, right? Because these two things essentially are inverse operations of one another and bring you back to the number under the radical. So what we've got here is negative 1. If I square I end up with a real solution, negative 1. If I try to raise it to the third power, well, that's kind of the same as just saying I times I times I, right? It's exactly the same as saying that. And the reason that I write it like that is because I can group these in a way that's going to be useful to me based on what I've already learned. I know that if I multiply those two i's, that's I squared, and then I still have this other I here, right? So I could rewrite it like this, and that would be useful to me because I know what each of these two things are. I know that I squared is -1, and I know that I is I. So that would just be negative I. If I raise I to the third power, I'll have negative I. If I raise I to the fourth power, that would be the same as me saying I times I times I times I. And again, I could group each pair of i's. And I know that I squared is the same as -1. So this is what I really have then. And -1 times -1 is 1. So actually, I to the fourth is what we're going for here. We are really going to start to love I to the fourth because it's the simplest case of I that we can deal with. It ends up giving us not only a real number, but the real number 1, which is really, really useful. So we find ourselves in this cycle because then if I try to do I to the fifth, well, that's just the same as I to the fourth times I, which just leaves me with I, right? Because I to the fourth is just 1. 1 times I is I. And it's just going to continue, right? We're back at I. I to the sixth is going to end up giving us -1. I to the seventh is going to end up giving us negative I. I to the eighth, well, since I to the eighth is just I to the fourth times I to the fourth, that's just 1 times 1, which is 1. And here we are back in this loop. So this I cycle is something that we're going to keep seeing over and over again. If I have I to the first, I have I. But if I square it, I have -1, which is nice. If I raise I to the third power, I have negative I, which is not so nice. But if I end up raising I to the fourth power, I get a +1. And then to the fifth, to the sixth, seventh, eighth, 9, 10, 11, 12, 13, 14, 15, 16. I can keep going over and over and over around in a circle. So we're going to want to simplify this a little bit for ourselves. But the I cycle is something we're going to have to keep coming back to and something that you're going to have to understand, these 4 powers of I. Most importantly, these two, right? I to the first and I to the fourth are big. Okay, so let's simplify a basic expression like I to the 20th. Well, I to the 20th, I could just write out 20 i's, right? That's I times I times I times I 20 times, like this. And this happens 20 times. Let's group it in a way that's a little more meaningful, though. If I write it like this, I to the fourth times I to the fourth, how many times do I have to do this? Well, that's I to the 12th, and here's I to the 16th, and now I have I to the 20th, right? This is more meaningful because I know that each one of these is really just the number 1, right? I to the fourth is 1. So I could rewrite this as I to the fourth to the fifth, because I do have 3, 4, 5 of these. And since I to the fourth is 1, that's really just 1 to the fifth. And I'm moving pretty fast. I do hope that you rewind and take a look at this. But this is just me using that I cycle from before. I'm implementing this. And what I could do is I could count 1, 2, 3, 4, 5, 6, 7, all the way up to 20. But we may see numbers that are much larger than 20 in the future, so we want to have a better way to do this than just counting. The last thing that we're going to do with our imaginary numbers is consider a complex solution like this. This is complex because it's going to have a real component, and it's going to have an imaginary component when we're done simplifying this expression. So anytime I'm squaring something, I know that I'm taking that thing that's being squared and really just multiplying it by itself. So that's just 2 minus xi times 2 minus xi. And when I do this, I know that I'm foiling. So I'm going to have 2 times 2, which is 4. I'm going to have 2 times negative xi, which is negative 2xi. I'm going to have that again. And then negative xi times negative xi is positive, because a negative times a negative is a positive. Xi quantity squared, right? I have xi times itself. So let's begin simplifying this. 4 minus, well, 4xi, right? Because I have negative 2xi and another negative 2xi. So that's just negative 4xi. I'm going to break this piece apart so that I have x squared times I squared. Don't forget that that exponent applies to both of these things. Okay, Now the thing I need to simplify is this I squared that's here. I know that I squared, if I look over at my I cycle, I squared is right here, that's -1. So what I'm going to do is replace that with a -1, and that starts to make it just a little nicer for us to organize minus x squared. I'm done simplifying, but I want to rewrite it so that I have my real component, which is all the stuff that we're used to seeing, negative x squared to the 4th. That's all real. And then our imaginary component is going to be the last thing we write. And our imaginary component is just anything that's involving I. So I've got our real stuff here and our imaginary stuff here. But this is the answer. Right there, just like that. That's as simplified as that gets. All right, I know that's quick, but really the new thing here is I. I is the square root of -1, and we're going to have to simplify some expressions that involve that square root of -1. All right? I will see you guys tomorrow.